All right. Thanks for coming to my talk, guys. I'll jump straight into it. So just to get started, my talk is titled 60 Microservices in 6 Months. And essentially what I want to talk about is the story of how me and my team at Coolblue were able to sort of migrate our microservices, our service-oriented architecture into the cloud in 6 months' time. So there's a bit of a story about how we went about this, the good, the bad, the ugly. So hopefully if you're in this sort of situation, you might pick up something from that or et cetera. So just a little bit about myself. My name is Flynn Bundy. I am a platform engineer at Coolblue. My job is to sort of facilitate helping developers get their applications out of their head and into an application and running in production. So everything in between. So automated testing, anything that the application actually runs on. All of the things that really facilitate getting applications running. So, and also a lot of the bringing developers together with our teams to sort of work on a solution that suits everyone best. Coolblue is a large Dutch e-commerce company. We sell everything from light bulbs to washing machines. So we're doing e-commerce, and that's sort of what we do well. So. All right, I'll jump straight into it. These are the couple of things that I want to go through. So I want to start off by talking about out with the old. So what we sort of needed to shed or really look into as part of our cloud migration, some things we needed to really think about when we started really doing this. So that's sort of want to highlight some of those. Infrastructure as code, a really important piece of how a cloud migration comes together, and a lot of the automation and facilitation of getting things running is all born and built with infrastructure as code. So I want to talk about that. Golden images, which is a really, really important sort of base fundamental, creating an image that can be reused and shared across environments. This is something that's, I think, a really important fundamental part of any sort of cloud migration or deploying applications in the cloud. Visibility, so how did we handle sort of things like monitoring and metrics? How did we get insights into these microservices? How did we really see what was happening before and after? And of course, everyone's favorite, automation, right? We're going to talk about automation a lot because everything we do is automated. This is what we do. And we'll talk about some chaos. So what is chaos? What do we do when it happens, and how do we do chaos? So, all right. So out with the old. I was actually tossing up between this slide. If you guys have seen Office Space, I was like, how do we, show, getting rid of something old? And this one sort of came to mind. It was either this or like Let It Go from Frozen or something. So if you guys have seen Office Space, this is like a really cool scene. So. I'll take you guys on a story a little bit, just about a bit of backstory. So back in 2015, Coolblue was a roughly around €500 million company, and we were sort of growing exponentially year on year. So as you can see, going back to 2000, just sort of starting out, and then getting to 2015, we had a lot of growth, and we knew where we were sort of heading. We could see our potential scale. We knew what we were in for in the next few years. So we sort of needed to really understand more about our systems and ensure that we had the scalability, and we were going to be able to continue selling products as the time went on. So back in 2015, we were noticing what was happening, and that really gave us some insights into how to sort of make our future more clear. So just to sort of have a look at what we had in 2015, we essentially had, this is sort of the stack that ran most of our microservices in the back office, right? So we had a simple load balancer, or a single load balancer, I should say. So one environment in production and one in acceptance. We had a single load balancer that was sort of round-robining traffic between 5 different web servers, right? So these were just 5 Windows Server, I think they were 2012 boxes. And we had one database. It was okay for a 2007 type of setup where we knew sort of our expected load. We sort of knew what we were dealing with when this was first created. But as we knew our projected scalability and we knew what was happening in the future, we weren't really sort of sure that this was going to meet all those requirements. One of the things about building microservices, we have these 5 servers, or we had these 5 servers, but all the microservices were deployed onto them. So it was like, you have these really small units of deployment, but when you deploy them to a set of 5 servers that they're all coupled next to each other, it sort of goes against the fault tolerance of building a microservice in the first place. And a lot of the things that we build them for, this design didn't really suit that. So we had a lot of developers who were really innovative in building great microservices and great products, but they were deploying them onto things that weren't really suitable to run that. So this was our stack, essentially, and it was okay to the point we could do stuff like this, right? If we lost a node, it was all right. We had 4 other nodes, and the traffic would just kind of continue as normal. It wasn't the end of the world. So, but we sort of had this happen every now and then, and this was really bad, right? Like nothing's happening at that point. That was a big single point of failure when we first started working with this and started getting more traffic in late 2015. And of course that's really bad too, right? Like this is probably just as bad. If all your applications rely on a single data store and something happens there, then you're going to have a bad time. So, like I said before, another thing is, we did this, right? We were deploying these applications, these microservices to all 5 of these instances at once, right? This was Octopus deploys sort of pushing these out, going, cool, that's our application's ready. Load balance is just going to continue as normal. So that was okay, but then, if that happens and you deploy some buggy code, all those instances are getting it, right? And it's just sort of part of that way of working with it, but it really wasn't scalable. We knew these were issues. So a lot of the time was spent like this, right? We were sort of like, when we started handling, we had to really dig into these issues, and we had a lot of them, and we were just like, wow, this is a SPOF, this is a SPOF, and we documented them. And we really worked a lot with our developers at this time to really build in a lot of automation. We started talking about automation and a collaboration culture. We started talking about this a lot because we had things going on. We needed to communicate with our developers all the time to really ensure that they were building things that were like going to handle failure and going to be able to run in our environment while we worked together to make a clear path forward of what we were going to do to sort of allow ourselves to scale moving forward from this. So this was sort of the start of things. So late 2015, we really started to talk more than ever before and really put together some principles and stuff, which I'll talk about shortly, about what we're going to do and handle this sort of stuff. And it was a very blameless type of affair. Like we talked a lot about postmortems, and we really went down the path of utilizing blameless postmortems and talking about that sort of stuff in a way where, no one screwed up and it's not their fault, they're not getting fired or anything. It was very sort of collaborative and a really good way to go about it. So this sort of outlined a lot of limitations, though. We saw them straight away. We had limitations. We knew them. We had to know the limitations of the platform we were building on and, of course, what we were building on top of, right? So we were running on-prem. We were running in VMware. We knew that at some point we were going to have to sort of either get really good at managing VMware and really get good at being hardware guys. Because, you'll think back from a couple of talks this morning, it was mentioned a few times, I think, if you're not really, really good at something, just stamp a check and give it to someone who is, because there's people out there who really love running data centers and making things that you can consume, and we had to know our limitations, and we weren't hardware guys, we weren't data center guys, so we were good at automation, we were good at sort of bringing developers together and designing applications and architecture and stuff like that, but we had to know our own limitations and highlight those, and it was sort of only when we started doing that we were able to sort of really see our future and how that was going to play out. So that stuck around until 2016. Here we were. We hit the expected sort of lines, about almost double sort of growth as such. We're coming up to the €1 billion a year. So we needed to make sure, as a €1 billion a year company, that those 5 servers, are becoming more and more important. So that was sort of when we hit really our big first scaling issue. And this is where we talked a lot about it. We said, hey, we need to do something. We all got together, the development teams and the operations teams at the time sort of got together and said, what are we going to do? So what are we going to do? Are we going to invest more, or are we going to look into public cloud? What's our step? So we all got to set together and made the decision from the development and operations team to sort of collaborate and work together on a spreadsheet that would identify what we needed to achieve, or what we wanted to achieve. What did we want out of a cloud migration? What do we want? So when we started highlighting those things, we could say, we want these are musts. We have some wants. We have some shoulds, coulds. Essentially, the Moscow method, if you've heard of that one, about certain things that we want as a company. As a developer, what do I want? As an operations guy, what do I want? So we compared the 3 major cloud providers and really did an assessment. We had accounts to each of them. We spent a lot of time working on them, doing proof of concepts, building things to really understand them at an in-depth level. And of course, me myself, I have a ops PowerShell background, so I was really interested to get more into Azure and really see that. But this really helped, going into this with an unbiased sort of look on things, really broadened everyone's mindset on not only public cloud, but the offerings, and also was very educational for everyone involved. So this was one of the best things we did. Having a bottom-driven team really make a decision, such a big decision, was really, really, a really, really good way to go. So I think we really won in this sense. So we ended up choosing AWS. for many reasons, based on the company needs and exactly where we were, and that's, there's a lot of things that we had at the time that suited that transition. So when we did this, we put a few things in place. We put a few principles in place that really sort of underlined what we wanted out of everything we were doing in AWS. So we said, from the start, me as a cloud engineer or someone who's going to be facilitating and building this environment, we want everything from code. We don't want anyone to sort of be able to do anything that is sort of a snowflake or a manual process where they might be doing something that really goes against what we're really, as a group trying to achieve. So we said, let's just make everything from code. So everything from infrastructure as code, anything that has to do with the CI/CD pipeline, all of that is in code. So that was one of the principles that we put in place. We really like the standardization approach. It was mentioned a couple of times this morning about, if you don't standardize, you're just going to fall into this trap where you have different snowflakes here and different snowflakes there. So standardization is, I think, probably one of the most important pieces about doing a cloud migration or actually having anything running in any cloud is like, how can I standardize this sort of stuff? How do I really bring that together and try and standardize as much as possible? We want it to be as transparent as possible. Like we really like the idea of we can build this cloud environment and the platform that holds it all together. And the transparency of that is we can have the code or whatever it is on GitHub, and everyone can sort of see it, right? Like we have that all internally in our private GitHub. And a manager can go and have a look at the declarative document that defines the stacks, or a developer can go and see exactly how something's built. So there's no sort of black magic going on or anything there. It's very sort of open and transparent about what we're doing. So we also want read-only access for everyone, and we do have, so for the testing, acceptance, and production accounts, of course, so developers we have developer accounts where developers can build fancy things and play around with things, but when it comes to testing, acceptance, and production, it was just read-only for everyone. And when I say everyone, it also included us, so we had the exact same rights as all of the developers, and that was for a reason, because we wanted to get ourselves in a position where we weren't saying, hey, we own this, we're going to tell you what to do. It's like, no, we're all equals, so we're all going to be in this together and all follow the same set of standards. So this was the next one, and we really liked this one. This was one of the first things that we started thinking of. Was like, if we're going to do this, let's do this with very sort of a modern way of approaching it. Really use the cloud platform that AWS provides us with. Really push it to its boundary where we build in the automation to support this principle. And this one was having a max 7-day lifespan of all EC2 instances. So in all of our environments, in production, testing, acceptance, we have alarms and alerts basically set up to say that anytime an instance even gets near that age, it will be essentially recycled. So this ticked off a lot of tick boxes. If you think about this, and we'll cover it more in a little bit. There's a lot of security things. There's a lot of you could probably even potentially hide memory leaks doing this sort of stuff. But it's a very interesting thing. It's a very interesting thing. But I'll cover that more shortly. So this was just the set of principles that we put in place. So we had to ask ourselves what could be better. We had this stuff running on-prem. What didn't we like about on-prem? What didn't we like about it? What did we find hard? What weren't we good at? So one of the first things that sort of came up was, we were using Ansible on-prem, which we all loved. We all really love Ansible. Ansible's a really great tool. And we were using it for things like, configuring our boxes and those 5 servers that we had before. So we still needed initial configuration, right? We still need some sort of configuration, on these instances when they come up. So we had to sort of think about how we were going to doing that. And we had to ask ourselves, do we have things like configuration drift? Will there be configuration drift on these servers? Do I need to bring these back into a line? Do I have varying configurations? Is it that complex or varying where I have multiple different types, right? And going back to that standardization principle that we made, it sort of goes against having a lot of varying configurations anyway. So we didn't really think so. Or complex and custom configurations as well. We didn't have many of those. So as much as we love configuration management in Ansible, it had a really great time on-prem. We didn't actually take it over with us into AWS because we didn't need to. Remember, it's about reducing that complexity where you can. It was also mentioned a few times this morning. It's like, if you don't really need something, even though you love it and you get emotionally attached to it, you really have to look into it and ask yourself the tough question. So that was one of the ones for us. The second one was Active Directory. We were like, do we need this? So really nothing was off the table when we started talking about what we do or don't need. So, domain, I don't know, user access, well, no one can log onto the servers anyway, so no. Group policy, no. Computer user management, no. We didn't need any of this stuff. So we scrapped it. We just said, let's just not make a domain. Let's just not do that? How would you really? I mean, there's a lot of automation you could build into having a 7-day instance lifecycle that integrates with Active Directory, and it's like, but what do we really get out of it? So when we sort of realized we didn't really get anything out of it because of the other principles that we had in place, we just didn't migrate it. So that stays on-prem and handles sort of the client side of things, as Active Directory does, but we don't use it for any of our server infrastructure or have any connection to it at all in AWS. So that was sort of the start of it. So we migrated together. So as a group, the developers and the operations team got together and started migrating. We basically split the services up into sprints and sort of all got together, worked it out with our product owner, estimated, worked with the development teams, did a lot of sort of paired programming and changing of the applications to make them a little bit more cloud native and a little bit more better integrated with the AWS ecosystem. But that was sort of the start of it. We really sat down and started doing that. So infrastructure as code, I want to talk a little bit about this and how this sort of fitted in with everything that we were doing during this time. So infrastructure as code, of course, when you start talking about the cloud and you start thinking about infrastructure as code, or the cloud in general, you just start thinking about that and you go, okay, how am I going to do things? Am I going to click everything together? Am I going to, who's going to do that and who's going to maintain that? And one of the things we didn't want to do is we didn't want to do anything we didn't have to do. We're trying to be really lazy here, right? So one of the fundamental parts of that was we needed a way to automate bringing everything up. Having that transparency, like in the principles, right? Having a way to show what we're doing that anyone could log in and have read-only access to and see exactly how it was done, or exactly how everything was built together. So for us, this was a big sort of change in mindset. Like we hadn't done infrastructure as code before. This is our first cloud migration, so we really had to wrap our heads around how all of that worked. And after we did, it was a really good thing. But there was a lot of situations where we sort of had to really change the way we were thinking about things. So for our testing, acceptance, and production accounts, we're using nothing but infrastructure as code. But of course, for developer accounts, we want to ensure that a developer has a good experience and they can sort of click around in their own account and build things. But when it comes to prime time, it's all infrastructure as code. So as far as infrastructure as code goes, we went with CloudFormation, which is a service offered by AWS. Essentially, you can take a YAML or a JSON declarative document and define some resources, essentially. So a load balancer, a security group, an instance as such. You can feed that through to the CloudFormation API, and that will sort of work out the ordering and sort of build those things for you. You might be familiar with CloudFormation already. It's very, very popular. And it really allows you to sort of end up with your finished result, right? A stack that contains what you define in your document, and it can take in some parameters, and those parameters can define the differences between environments, right? So a very sort of basic way of bringing up infrastructure, but it was something that really helped us get off the ground and starting. So how we did this, essentially, was we decided to have a common stack, right? So we essentially said, we're going to have one YAML file that defines a specific application. Everything was broken up into just that application, right? Like everything, when we start talking about microservices, we can't mush things together. There have to be a clear sort of bounded context between these services so that we can clearly identify what they do. So we had one common folder, and that common folder contained a YAML file for each of the services as such. So here's an example, like we have a service called back office product, and that YAML file contains the load balancer, the security group, everything about it, And then we also have a different folder for production, acceptance, and testing as well that contains the parameters that will be fed into those stacks. So always one stack, so you end up with testing, acceptance, and production the exact same. There is no way they can be different because they're all built from the exact same template. Just different parameters passed in that define maybe the instance size or how many we should auto-scale to, that sort of thing. And even the instance size we keep exactly the same in acceptance and production. So we want to make sure we're getting the identical environments, and this is one way to do that. So we have the same thing in TeamCity. We love TeamCity. We're big TeamCity fans. And essentially, we replicate that same sort of concept, right? We have like, Coolblue production or Coolblue acceptance or Coolblue testing. And essentially, all you have is those services broken down again. And you have essentially, when you were to run this, it would essentially pass in the parameters to that common stack and create your stack. So TeamCity is essentially our deployment interface and allows us to sort of have that abstraction layer where none of us are actually having to run anything from our laptop because, we don't have access to anyway. But it would be really hard to sort of keep track of who's running what and anything without some sort of way to have a deployment interface. And the cool thing about this was that we had the user that was basically executing these commands on our behalf was the only one who was able to actually write to those APIs, right? So, or actually do a call to those APIs to actually create from them. So we were never able to do it. It was just that user as such. So that helped a lot, and that was like sort of the one entrance point into actually creating anything in CloudFormation. And again, all of the things you see in TeamCity as well are also created from code as well. So that was sort of one of the things for us that was like, is this possible? How do we do this? And TeamCity let us do that as well. So, a big part of infrastructure as code as well is making sure that we're validating, making sure that we're linting, making sure that things are going to actually run before we sort of push that button and go, oh, yeah, okay, cool. So in order to do that, in order to get sort of everyone on board, we built a custom linter that works with CloudFormation, and we also utilized the CloudFormation validation APIs to ensure that everything's valid and up to date before we actually run any of those stacks. Okay, so we'll move on to golden images. I'll sort of bring a lot of these back in together later on, so you will see infrastructure as code come back. So golden images. I think this is a really interesting topic, and it's one thing that you might be familiar with. So in like VMware world, you had like templates, right? You had some sort of base level where you sort of started everything from. When we started looking into AWS, we were like, okay, so do we just grab the AMI and then use configuration management to configure it as such? And that's a pretty valid option. A lot of people still do that. Just start off with the base Amazon machine image, and then sort of pack in what they want. They just use Ansible or Puppet or whatever to put things on. But we wanted it to be a bit more streamlined and a bit more strict about how we're going to go about it. So what we did was essentially take advantage of the shared responsibility model that AWS offer. So they have as part of that shared responsibility model, they're responsible for patching the underlying operating systems of those images. So anything that's owned by Amazon themselves, they'll patch it and make sure that it's up to date every month. So we really wanted to take advantage of that. So what we did was essentially built a little sort of wrapper around that where we have TeamCity actually calling out to a tool called Packer by HashiCorp. And Packer is responsible for therefore going out to based on some configuration that we define for Packer, going out and getting a specific AMI that we've said, and then running some provisioners on it to get things. So maybe I want the base installation for Datadog. Maybe I want Splunk agent or some configuration for IaaS, something that defines a base level that we want to start with and then add in a couple of things on top. So we would essentially run this. So TeamCity would actually run this every week for us and create a new image. This is actually the process here. So this is a scheduled task sort of thing that runs in TeamCity, calls Packer, creates a new image, and then that image essentially is all ready to roll, right? That image becomes the image that's the start point for all of our stacks at that point. So that looks like this, right? So once we have that image created, TeamCity can then share that image with our accounts, right? So we have a testing, acceptance, and production account other than our developer accounts. So these are our main accounts. So what we want to do is, because everything's built in CloudFormation, we have this ability to sort of pass in a new AMI into a specific environment and update our stacks with that new AMI. So this is what we do essentially. We take that image and we share it with the testing account. And when we do that, we also execute CloudFormation for all of the testing account with that new AMI. So they take advantage of the autoscaling group rolling update policy, and they can essentially pass that AMI out to all of the instances, and the instances will handle that. They'll handle the swapping of the instance over. They'll handle sort of the health checks and making sure that we don't get any 500s during this time. So that process is really, really handled and integrated into the way the Elastic Load Balancer works and the autoscaling group. So once we were able to sort of validate that we didn't break anything, everything worked in testing, maybe we upgraded the Datadog agent or something in the base image this week, we were able to sort of say, okay, everything looks good. We had a few automated tests in place as well after it's shared. We were able to share that with acceptance. And again, the same thing happens. So as soon as we share it with acceptance, CloudFormation gets called for acceptance, everything basically updates their stack, and we get a new box. We do the same thing with production the day after. So these are all sort of one day apart, so we can ensure that we didn't actually sort of really break anything, and it was hiding from us. But this is such an important part where sort of alerting and monitoring come into it, which we'll talk a little bit about later. But we really need the insights to see if everything's working as intended from doing this. So that's essentially how that was working. So by doing this, you refresh all of your instances, right, all the time. And we have alerts based on the age of an instance. So this is for the last month or so. And we have basically a line in Datadog to say, we can see straight away the average age of all of the instances in our environment. So we're positive that we don't have anything older than 7 days. And of course, by sharing that new image out that gets built every week automatically, we're guaranteeing it because all the stacks are based on those AMIs. Those AMIs are all brand new and built every week. So we're able to sort of keep everything very, very fresh. And you might ask, like, why weekly, right? Like, patches are only monthly. But there's also this, did everyone remember, like, when people were like, oh, did you test your backups? Like, you remember that sort of thing? And no one, and like, everyone was like, oh, yeah, no, we don't do that. We make backups, so we don't test them. So we sort of use that similar concept, right? We're like, well, let's just test our automation all the time. Let's just, like, even if it's just every week, we're not paying anything extra. Like, if we just did it every month or every week, it's, like, very, very minimal to get the benefit out of knowing that our automation is constantly working and we're getting that feedback. So that's really important to us. Okay, so speaking of automation, we do a lot in, we don't want to do anything, right? We want to automate everything, like everyone here, right? So we do a lot with tags. When we talk about CloudFormation, we really bring a lot of our automation and everything that's sort of happening underneath the hood to tags that are defined in our CloudFormation stack, right? So say, for example, maybe the most important tag we use is the app group. Like, what app is this? What microservice is this? What is the identification for this? We don't use server names anymore like we used to. We're all in the cattle business now, so we need some sort of way to identify a group of an application. So we use that here in this app group tag, and we also have a few other ones that define a couple of other things about what's happening. So there's about 6 or so, such as the environment and stuff as well. So why is this important? This is important because we define all this in CloudFormation, and essentially what happens is when CloudFormation brings up a stack or brings up an EC2 instance that's inside of a stack, what it does is essentially call something called user data. And user data essentially is just bootstrapping, right? It's calling some scripts that will essentially run and do something on your behalf. So that's one PowerShell. So for our Windows side of stuff, we use PowerShell, sort of a set of functions that will handle executing certain tasks based off those tags, right? So the tag, like, environment is production. That's really important information. These get fed into an internal function that runs in user data to dictate how that machine is sort of slightly configured as opposed to the other machines. Because remember, everything's really based in Packer, right? We're packing everything in, and then we just want these tiny little changes on top, like the production environment versus the testing environment, right? That's really important information. Or is it a web server? Like, if it is, then we want to make this tiny little IAS change, right? This little tiny thing. So, you could say that this is sort of what configuration management does, and that we are sort of doing configuration management here at a basic level, and that is true. But it's such a small amount that we really wanted to take, a very basic approach to it and not add in a complex tool or any sort of unnecessary overhead. So the app group, like I said, is the most important one. This word that is in the value, whatever that is, dictates that whole idea of what that stack is. And this goes into things like, Datadog, like, what it's going to be identified in Datadog as, what it's going to be identified in Splunk as, which index it logs to, which app group it ends up in Octopus Deploy, that sort of stuff. So very, very important. So just reiterating that is sort of what happens here. Like, if we have reordering, yeah. We end up with the right Splunk stuff, the right Datadog stuff, anything to do with IAS that might happen. So it's a really, really key part of what we're doing. And because it's static as well, we can define it once up front in the CloudFormation stack. And because we have sort of the standardization approach to our CloudFormation stacks, a lot of microservices, because they're different at an application layer, but the stack is the same, you're essentially using the same stack most of the time as well. So that's something that we're always trying to squish that down and become as more streamlined as possible. So this is an example, right? Like, you end up with production, that's there because of the environment. Then you have something like restocking or whatever it is that represents the app group. Same as is with Datadog, where you end up with all that stuff in there, so you can sort of filter on the things that are specific for that application. Same with Octopus Deploy, of course. The environment is really important, right? You want to go make sure that you fall into the right group in Octopus Deploy, and the right application gets deployed to the machine. That's pretty important. So speaking of Octopus Deploy, like I was saying, this is about automation. So everything we do, from release management through to inspection, all that stuff is all automated for us in a combination of TeamCity and Octopus Deploy. So we have, just as far as like pull requests is concerned for a specific application, we do continuous testing and integration at the top, and then we have a build phase, and then that's essentially pushing a new package to the feed, the Octopus feed. Then we have the create release step, and then the deployment phases as well. So all of this is sort of automated through. When something gets merged to master, we're going to have an automatic deploy through to acceptance. And then depending on the team, it can be to production, or if they're more comfortable with releasing or deploying themselves into production, they can just click deploy in TeamCity. And all TeamCity is doing is essentially interacting with the Octopus API, which is really, really helpful. Cool. So I want to show you guys a little bit about visibility and how we sort of really get insight into things. And I think this is really cool. Like when we first started working, thinking about how we're going to do our cloud migration, we didn't really have great ways of monitoring and logging and really seeing what was happening, right? We didn't really have good insights. So we take advantage of Datadog, and this is what we're just looking at then. So in Datadog, it's, you get so much insight into what's happening in your environment. Like you can see about how sort of everything works. You can see the configuration as such and how things tie together. And you can also see like up here, like when you actually drop down, you can have a variable in that app group. Like so everything ties back to that app group, right? When you start to piece it together, you can actually choose a different app group and see metrics for a different application. Or you can simply just choose into a different environment and see metrics for a different environment as such. So you really, by utilizing that single point of reference to tie it back to one single tag, you're able to get a lot of information. So this is essentially what our infrastructure looks like, but this is probably not the best way to put it. Again, using that app group tag, it is a lot different to look at. These are just all different microservices now split up into different app groups. So we really get insight into our environment and what it looks like at a top level. But this wasn't really enough for us. We were like, okay, so like if I had someone who started tomorrow, like how do I explain this? Like how do I show the interconnectivity between these services? Like how do I map this out? So one thing that we really got into, and I'll just bring this up. Probably should have brought this up before, but only take a second. Is there's an open source tool called Visceral by Netflix, and we needed a way to sort of really identify how services are going to talk to each other. We didn't really understand it at first. This was sort of before tracing became a really big thing. Now you see a lot of work being done with tracing about tracing requests. So we needed a way to sort of do that as well. And we looked to this tool called Visceral and implemented into AWS with something called VPC flow logs. So VPC flow logs allow you to sort of get real-time traffic insights into what's happening in your environment, so you can see everything as it goes. So we were able to sort of take advantage of that. This display looks a bit interesting. But this is sort of our microservices as they're talking to each other in real time. This is running locally, but this is the same essential data as such. And you can sort of you can see sort of exactly what's happening in real time. So we know that this thing is talking to that thing, or this thing is talking to that thing. We can see the traffic as it sort of flows around our environment. And this is really good for a lot of reasons, right? There's a lot of things in here, like even at a documentation level, right? So if someone's like, hey, how does this work? How does this application work? How do I find out more? We have a live up-to-date I think it's per minute up-to-date interface where we can sort of look at that sort of stuff and show exactly what might be happening at any time. So this is all normal traffic, but of course you have different ways to represent things. Like so here I can clearly see that there's a failure happening, right? Like the reordering application cannot send to Redis, right? I mean, this is the sort of thing that you can instantly identify at a top level, and you can just sort of, if you look at Redis, you can sort of see the incoming connections from reordering at a 100% error rate. So, that sort of stuff to us, we didn't have before, and it was really hard to implement this, and it didn't even really matter so much, when they're all on the same server, like we had with our original 5 servers, it's like, well, it's great, but like if the servers go down or something, it's like there's no sort of fault tolerance there anyway, so we needed to make sure that when we did this, and if we did it properly, we were able to have a way to map those services to something like this, where we could really, really get insights. And of course, all these endpoints here are just essentially load balancers, like the front ends for the service as such. So we also have ways to identify funny things that are happening, right? Like this is sort of weird. Like if you look at this, you can instantly see there's something weird going on with this application, right? This is receiving like way too much traffic. And you can see as well, like if you broke it down, you could see like, hey, you're getting a little bit of errors happening in there. It's like a very small amount, but there's a lot of traffic going there. So we can simply identify anomalies that are happening in the environment by having a quick look at this, but it also comes back to tying in with our alerting and monitoring systems as well. Like we do proactive alerting to make sure that everyone's aware of what's happening at any time. But this is just part of that overview. So I will just kill that off. Yeah. So, okay. All right, so that's sort of like a little bit of an insight into visibility. We also use Splunk. We absolutely love Splunk. I think that's, we've really been able to really extend our applications to take advantage of structured logging in Splunk and really get insights from that. I think without that, we weren't able to really see inside the applications and what was happening inside them. So that's helped a lot. So yeah, chaos is a really interesting topic. I think you might be familiar with the idea of chaos monkey and all this sort of stuff that people sort of talk about a lot. Yeah, we really like the idea of this sort of stuff, and because we have a very sort of young environment in AWS, like we just moved this in, we went down the approach of saying, what do we want to do? What do personally we want to do, and what do the developers want? Do they want something like that? Do they want a service where they can actually ensure that their application is self-healing? Is it fault tolerant? Is it scalable? Like, can it handle failure? Failures are going to happen, and I mean, it wasn't even that long ago. We had, I think there was a smaller outage with S3 recently, a couple of months ago. Yeah, and it was mentioned before, like Netflix was one of the only ones that didn't go down during that time because they build this sort of stuff into their applications to handle failures, So we really like this idea, and we talked to our developers. We got them excited about it. We started building things and helping them and working with them to build applications that were built in this sort of way. Right? So this is sort of just like a normal application layout, right? Rather than our old 5 servers, now we have the one elastic load balancer entrance point, and then we have an auto-scaling group that might have 3 or 6 instances, depending on what's happening. But a normal application, right? Maybe it uses S3 to store some stuff and work with some data. So we're pretty confident stuff like that can happen, right? We can still burn an instance, and things will function as normal. So that's sort of cool, and that's sort of what Chaos Monkey does, right? It just kills instances, right? And that's sort of cool. But we want to make sure we're sort of going to that level where we can really ensure that things like this happen, right? So if the S3 bucket for EUS1, you just lose connection to that. Like, we want to make sure the application can handle that and actually sort of start writing to EU Central, or somehow, somehow work with that other bucket to continue some basic level of functionality without sort of causing a cascading downstream failure of all the other microservices. We don't want something to happen where it fails and then everything just fails, right? We want to build these in a way where they can either slow down, or they can just fall over to a different service in a different area. So that's something that we've really been focusing on. And also, like we said before, in that looking in Visual before, if you had like 1 million requests a second coming in, you can spot that sort of stuff. And that's something really good to test your application with as well. And we really sort of do that a lot. We make sure that we test this sort of stuff. And yeah, that's sort of one of the ones we do a lot. Like, how many requests can this handle before it sort of falls over? Like, and will this application receive those many requests in its lifetime? Like, is it expected to? So we take a note out of the Google SRE book here, like if you guys have read that book, but there's a lot of stuff about SLAs on services and all that sort of stuff, like keeping a good SLA on a service, understanding the underlying functionality of what the platform is and the functionality of that. So we make sure that we test all this stuff, and we do this in production because we're confident that it's not going to break anything, but we only do it on applications that we know have SLAs that are far exceeding their monthly budget as such. So if we haven't had any sort of outage or any downtime with a specific application that month, but it maybe has a 99.5 uptime, then we have 7 hours, essentially. So that's a lot of time. Not that we're going to go and break it, but we're testing these and ensuring them with the help of those developers to understand any sort of faults or flaws in their system. So we do all this in an automated fashion to make sure that is happening, and we do this in production every day. And 99% of the time, no one notices anything. So it sort of works in that sense. But the most important part about it is that the monitoring that comes out of this, the results, the metrics that show that the application was stable, and we can sort of work with that team to prove that with them. And that's the most important part of doing anything related to chaos engineering. Okay, I have 5 minutes. So why we do that is because we build things that matter. We really want to build things that we are really passionate about and things that we're wanting to do. Like if we have a crazy idea like that, we build that ourselves. We look to the community. We look for inspiration from everything that's happening and the people around us. And events like this, we get a lot of inspiration from to build things that we find really cool, things that matter to us, things that matter to our developers and our customers at the end of the day. The most important thing. So conclusion. How did we go with our wrap-up? So this is this year. So I mean, so far our migration has been a success. We're just finishing off our migration now. So we're able to sort of facilitate the scale of the company as we head towards the end of 2017, where we've sort of surpassed where we thought we were going to be and really allowed the company to that room where they can breathe and extend on what they had. So this was really why we set out to do this in the first place, right? To make sure that we could grow and that we could scale in the future. So this is our goal has really been achieved. It's not done yet. There's always more to do and more to innovate and more to sort of build on. But this is sort of our immediate goal as such. So I have a couple of things to look at. I mean, these will be in the slides as well. Some things that really helped me when we started building this sort of stuff. So if you're interested in Visitor, take a look at that. The Principles of Chaos, which is like the sort of made by the guys at Netflix, which is a lot of fundamentals about how, what is chaos engineering, how it works. I'm happy to talk more about, of course, all that anytime. Basic Monkey is like a forked version of the one we use sort of internally. 12-factor app, if you haven't read that, check that out. That's really cool. And of course, if you're interested in any sort of this sort of stuff, please let us know as well. Like we're looking for people who are passionate about this stuff, who love building great software and love being innovative. So please have a chat to us after this or anything if you're interested in that sort of stuff. But yeah, is there any questions? I think I have a couple of minutes, right? A minute or so. Yeah. Any questions on anything? Yeah.
Have you got anything one particular that you need to address next?
Yeah. I mean, there's a lot of stuff, right? Like, I mean, it really comes down to the direction on what the business wants to take, right? With things like if it's like, hey, we want to save X, Y, Z money, right? Then sure, we have a financial thing that we need to look into and solve that. I mean, we have a pretty robust system, but it was just a lift and shift. So there will be the whole revitalization part where we're like, hey, do we need a server for this? Let's talk about Lambda. Let's collaborate. Let's build something that's more event-driven. Let's take use of, event sourcing and stuff like that to really get more out of the platform. So there's always more in that sense. So I think, yeah, redesigning apps to be serverless is probably one of the big ones. Yeah.
Did you migrate away from SQL Server, or how do you deal with your data?
Yeah.
Because you said you destroyed instances every 7 days.
Yeah. So we're not destroying databases every 7 days, so let me tell you that. No, we use RDS, right? So we have in RDS, we're able to set up a multi-availability zone database, and that is fully managed. We don't have to worry about that. Again, no one in our team was a database expert, so we're like, why should we do something that we're not good at? let's just stamp a check and on we go, right? It's about productivity and doing things that we're good at. So yeah, now we've moved into using DynamoDB for a lot of our NoSQL stuff, and we use Postgres for relational data. So yeah.
You mentioned standardization, but what standardization do you enforce among your microservices, and in particular, in terms of how they communicate?
Yeah, so I mean, we're not really enforcing a protocol as such. Like we're happy if people want to send messages, a microservice want to communicate over a message bus or whatever, or HTTP, as long as they're not having a huge HTTP nested call stack where it's like 5 calls on top of each other that end up costing 500 milliseconds or something. So the standardization part is more from if we're building a stack in CloudFormation, we want to make sure there's not really, we would have a discussion with the developer if they're like, oh, I want Kinesis plugged in with Dynamo, plugged in with Lumberjack or something. Like we would sort of talk them together and be like, do you really? Or do you want, what's your end goal, right? And can we bring that into our standardized sort of way of building a stack? Because most of the times the changes are in the application layer rather than adding some fancy feature on that they don't really need. So
do you have a group of people who go around enforcing that?
Well, it's not really, we don't like to think of enforcing, but we're definitely communicating and learning about it as well. As we learn, they learn, and we all learn together. So we do travel around to the development teams. We're not a team that sits in their room. We're constantly sitting with the developers every day. And we have like 7 or 8 different developer teams, so 80 .NET developers that we sort of travel around with and work with and make sure their application's cloud native, yeah. Is there a question at the back? Something? Yeah? No?
No.
Cool. Awesome. Yeah.
Is there a use case wherein you had to deploy a set of microservices, and how do you deploy them?
Yeah, so everything's decoupled, right? So, in a sense where a microservice is individual, it's its own entity, it's independently deployable, it doesn't have any sort of tightly coupling. So we haven't run into a situation where that happens because we sort of have those standardized sets in place. Like if someone's building a new application, they follow a template and they follow a way of building that application, which is not tightly coupled. So when we migrated things at first, we're like, hey, we noticed like this application is pretty tightly coupled here, like to this other one, and then we sort of worked with the developers to help them split it and make it sort of independently and deployable as such. So before we moved it, because we don't want to do that once it's up there, otherwise we're messing it up a little bit. Cool. If there's no other questions, it's.
I'm conscious that we're sat between people and lunch, so. On that note.
Yes. Okay. Thanks.